Okay, problem 928. It tells us to, 928 is a little bit of a longer one. Do make sure that you follow all of the directions though. So it says to read the information below, then follow the directions that follow. So let's go ahead and take a look inside of this green box. It says exterior angles are formed by extending a side of the triangle. The two angles across the triangle from the exterior angle are called remote interior angles. In each figure located below, part A, angle A and angle B are remote interior angles with respect to exterior angle BCD. So, what they're saying here is they are telling you that exterior angles are made when we extend a side of a triangle. So if you look at this, at all of these under these are exterior angles, you will notice that this side of the triangle is being extended. So it is that angle right there that is the exterior. Remember, exterior means the same as outside. So it's that angle that's formed by extending a side of the triangle. And you'll notice that in all of these other triangles that they show you, we're just extending a side. And then it's the outside angle. Extending. Whoop. And it is the same for this one. We extended this side. We extended this side. Now in this one, they show you how they extended two sides. But in this case, the exterior angle would be here and here. Notice how this here is not considered an exterior angle. Well, that is because that angle would be connected to both of the extended sides. So that would not be a remote that would not be an exterior angle. Now they give you some examples of things, or I guess angles that are not exterior angles. So if you look at this one right here first, you'll notice that they've extended a line, but it's not straight with any of the sides of the triangles. So that does not work. And you'll notice with this one right here, they've extended two sides of the triangle. So that angle that they show you cannot be an exterior angle because it's connecting to both of the extended sides. Now, we could have one here, we could have one here, but the one that they give you is not an exterior angle. And finally, this one, they do extend a side, or not a side, they do extend a line, but it's not in line with any of the sides of the triangle. So those are some examples of angles that are not exterior angles. All right, let's have a look at part A. So it says, on the lesson 913 resource page, well, we don't have that, so you are going to have to copy this table down. It says to calculate the missing angle measures in each figure and record them in the table. When you have completed the resource page, look for a pattern in the relationship between the measure of angle BCD, which is the exterior angle, and the sum of measures of angle A and angle B, the remote interior angles. Notes that the measure of angle BCD means the measure of angle BCD. Similarly, the measure of angle A, or M of M angle A, means the measure of angle A. All right, so our first step is to fill out this table. So you'll notice we have a row for each of our figures. So I'm going to go ahead and start with figure 1. So figure 1, if we're looking for the measure of angle A, how could we find that? Well, we know that the measures of the two remote interior angles equal the measure of the exterior angle. So what this means is we have our exterior angle, which is 56 degrees. That's our exterior angle. Now, the two remote interior angles are going to be what are opposite of that. So the one right next to it, this angle here, that cannot be. It has to be the ones opposite. So what plus 20 would give me 56? Well, 36. So 36 degrees. All right. What about the measure of angle B? Well, it gives us the answer right here. Here's the measure of angle B, and it is 20 degrees. All right, what about the measure of angle ACB? So that's going to be the one that is next to that exterior angle. What is the measure of that angle? Well, the measure of that angle, if we know that the measure of angle A and B are 36 and 20, we know that all three need to add up to 180, so the measurement is going to be 124 degrees. All right, the measure of angle BCD. So that is our exterior angle. That is 56 degrees. They give us that measurement. And then finally, they want to know what is the measurement of angle A plus the measurement of angle B. Well, we have A and B. A is 36, B is 20. So 36 plus 20 would give us 56 degrees. Okay, not bad. Let's have a look at figure 2. All right, figure 2, the measure of angle A. Well, that's going to be this one here, and that is a right angle symbol, which means it is 90 degrees. The measure of angle B. Now, that is this angle here. They don't give us that one, but we can find it out. So we know the inside or the interior angles of this triangle should add up to 180 degrees. Well, I have one that's 33 degrees, one that's 90 degrees. So I add those together and subtract from 180, and I should get 57 degrees for my angle B measurement. Now I need to find the measure of angle ACB, which is this angle here. It's given to me, and that is 33 degrees. All right, the measure of angle BCD. Now, angle BCD is going to be this exterior angle here. So notice how that angle plus my measurement of this angle make a straight line, which should add up to 180 degrees. So I'm going to do 180 minus 33. that gives me 147, which is the measurement of that exterior angle. And finally, they ask for the measurement of angle A and B when we add them together. We already have those, and when we add them, it should be 147 degrees. All right, let's go ahead and take a look at figure 3. Okay, figure 3, we're looking for the measure of angle A. Right here, gives it to us, that's 55 degrees. The measure of angle B is also given to us right here, that is 27 degrees. Now, we need to find the measure of angle ACB. So that means going from A to C to B, which is this angle. That angle we don't know, but we know the 3 inside angles of a triangle should add up to 180 degrees. So, knowing that, I'm going to add 55 plus 27, take that sum and subtract from 180, and I should have 98 degrees. Okay, now we are being asked to find the measurement of angle BCD. So BCD is this external angle, and it is not given to us, but we know that the measure of angle ACB, which is this one here, plus my measure of BCD should add up to 180. So I'm going to do 180 minus 98. That gives me 82 degrees for my exterior angle. Okay, finally we need to add the measures of angle A and B, which is 55 and 27. When I do that, I end up with 82 degrees. All right, and lastly, let's have a look at figure 4. So the measure of angle A is not given, and neither is the measure of angle ACB. But we have this exterior angle right here, which is 136 degrees. So I'm thinking instead of finding A first, what I'm going to find is my measure of angle ACB first. So 180 minus 136 would give me 44. So that angle is going to be 44 degrees. Now I have 2 of my inside or interior angles for this triangle. I know that all 3 will add up to 180 degrees. So what I'm going to do is add 21 and 44, take that sum, subtract from 180, and I should get 115 for my measure of angle A. My measure of angle B is given, that's 21 degrees. Now the measure of angle BCD, that is this exterior or outside angle. That's given and it is 136 degrees. And finally we need to find the sum of measures of angle A and B. So that's 115 and 21. And when we add those, we will get 136 degrees. All right, so that's A. We completed the table. Now let's have a look at parts B and C. So B says compare your results for the measure of angle BCD. So that is this one here. and the sum of measures A and B, which are the remote interior angles. For each figure, discuss the observations with your team. All right, so what I notice right away, and I hope you do too, is that the sum, if we look at the sum, which is going to be this column here, so that is the sum of the remote interior angles I noticed that the sum is equal to the measure of the exterior angle. So the sum of the remote interior angles is equal to the measure of the remote. Oh, I'm sorry, it shouldn't be remote. It should just be exterior. All right, again, the sum of the remote interior angles is equal to the measure of the exterior angle. All right, and part C. Write a conjecture about the relationship of an exterior angle to the two remote interior angles. Well, my guess is that, if it worked in all four of our figures, we saw it firsthand in part A. We even talked about it in part B. So I'm going to say the exterior angle, I guess I don't want to say the, but we'll say an exterior angle is equal to the sum of the remote interior angles. All right, and that's all for 928.